Hello, and I want to welcome you to a discussion on simplifying radicals. A square root is simplified when the radicand contains no perfect square factors. The product rule for square roots: if the square root of a and the square root of b are real numbers, then the square root of a times b is equal to the square root of a times the square root of b. Okay, now let's apply that with examples. Use the product rule to simplify the radicals. So looking for the perfect squares, if we refer back to our original video here, let me copy and I'll go to where we were, and I'll actually paste these in as a reminder. And I'll scroll back up here. Okay, the numbers that we need to be looking for are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and 144 inside the radicals. So looking at number 1, you can just think of the product of 20 okay, and what things can we multiply to give us 20? You can think of 1 times 20, 2 times 10, you can think of 4 times 5, and I think those are the ways to get 20. Now we need to look for perfect squares. This won't get us anywhere because that's what basically we're working with, just 20. 2 and 10 are not perfect squares, but 4 and 5 contains a perfect square. It contains 4. So we think 20 is the product of 4 and 5, and 4 is the square root of 2, because it can be written as 2 squared. So we take the number, the base of the exponent, and we can pull it on the outside of the radical. We pull out the 2, since we could write 4 as 2 squared. Remember, the square and the square root are inverse operations, canceling each other out. So that's how we're able to pull 4 out, and that takes care of the 4, but we cannot do anything with 5 because 5 is prime and it cannot be broken down any farther inside the radical. So this is the answer for that example. Okay, looking at our second example, we have the square root of 50. So we need to look through our product of 50. We look for things that when multiplied together give us 50 that make square roots. Now 1 times anything, that's really not going to get us anything rid of the radicals, so we can ignore that. So we have 2 times 25 and we have 5 times 10, and we need to look for something that is a perfect square. So if you look back at that first slide, you'll see that 5 and 10 are neither perfect squares, but 2 and 25. The 25 is a perfect square, so that's what we want to use. And 25 breaks into 5 squared. So remember the square root up here and the square are inverse operations, so that would just leave us with the big number of 5. So we pull the 5 outside of the radical, and inside we had to leave what we were unable to use, which is the 2. And that is your final answer. Looking at number 3, here on the right side of the slide are the multiples of 72, the factors, that when you multiply together give you 72. This first one won't work, and we're always looking for the highest perfect square. And if you see, there are 2 different sets of perfect squares. We could go with the 2 and 36 or the 8 and 9. You could go with either set, but with one you're going to have to go a step farther. If you choose the 2 and 36, you're going to get the highest value possible. So you can think of the 36 being equal to 6 squared, knowing that if you square root both sides, you're going to get 6 equals 6, because over here the square root and the square cancel each other out. So what you want to pull out is a 6 from the 36 being square rooted, and inside you have to leave what you weren't able to work with, or just the 2. Looking at number 4, we have the square root of 90. On the right side of the slide we have the factors of 90, and if you look, these will not work as perfect squares except the couple 9 and 10. 9 you can think of as the perfect square due to 3 times 3, or 3 squared. If you were to square root both sides, you would just get 3. So, or you can just take this base number that's being squared and pull it outside of the radical. So pull it outside, and what you're left with is the number you weren't able to work with, or just the 10, because we worked with the 9. Okay, with number 4, the product of 0. You can just do 0 times 0. So what's going to happen here, you drop down the 4, and the square root of 0 is just 0. So if you multiply these together, 4 times 0 is just 0. With our final example for this video, we have negative 9 times the square root of 18. Okay, so we have to think about the factors of 18. 1 and 8 won't make a perfect square, and 3 and 6, but the couple 2 times 9 equals 18. 9 is a perfect square, and as before we've discussed, 9 can be written as 3 squared, where we take the large number being squared and we pull it outside of the radical. Well, we have that 9. Let's go ahead and pull the 3 out right beside it. And what do we leave inside? We leave inside the number we were not able to work with, or just the 2. So now we have to simplify this multiplication of 9 times, negative 9 times 3, and negative times a positive is a negative, so 9 times 3 is 27. And then you leave the square root as it is.